Laid out a couple of automotive relays here. This is a basic 5-prong single pole relay. We're going to keep this video as simple as possible to explain what a relay is. A relay is basically just a switch. Don't think of it as anything else. It's just a switch that uses a small amount of electrical current that can turn on or off a device that uses a much larger electrical current, if that makes sense. So it's basically a low amp switch that can turn on or off a much higher amp component. So most relays is going to have some type of schematic printed on the relay. And all this is telling you pretty much how this circuit is being controlled. So I'm going to break down what this schematic means and what is this diagram telling you. All right, guys, so let's break down relays and how they work. You see the schematic here. I went ahead and drew it on this piece of paper. Like I said, I'm going to break it down in a way that's really easy to understand. So the 86, the 85, the 87, the 87A, and the 30 are all prongs. Those represent prongs, and you can see that each prong is numbered. I don't know if the camera can pick it up, but you can see there's a number on each prong, and that's gonna basically represent which prong is doing what in this relay. All right, so it's important to understand the heart of the relay. The heart of the relay is the electromagnet switch. Okay, 86 and 85 is the heart of the relay. Okay, if you don't learn anything else from this video, learn that 86 and 85 on this relay is just a switch. No different than this. Okay, this is a mechanical switch that I use my finger to open and close the circuit. This is an electromagnet switch. You don't have to physically push the switch. Electricity goes through this device, okay, and it creates magnetism. That magnetism then sucks this contact closed with 87. Let me illustrate. So we all know how a switch works, right? So this light is being controlled by a switch. This light cannot turn on if the switch is open. All right, so an open circuit will not allow the light to illuminate. It has to be a closed circuit in order for this light to illuminate by means of this control device called a switch. So we know if we switch this switch to the closed position, then electricity can then pass through and illuminate the light. So a relay is pretty similar to just a basic switch. All right, so here's our relay again, now that we understand how a basic switch works. All right, so here's our control side of the relay, or our switch, same thing. This switch is energized at 86, okay? So when the electricity goes through, it creates the electromagnet. The electromagnet is then drawn over to make contact with 87. So now we have a closed circuit between 87 and 30. Now 30 in this particular diagram is our power supply. And we want to send power to our AC compressor or perhaps our fan motor. And in order to do that, we're going to energize our switch, which is going to draw over our power supply to make contact from 87A to 87, which will then power our AC compressor. So hopefully this is a basic, simple diagram on how a basic automotive 5-prong 1-pole relay works. They're really not that complicated, and I tried to explain to the customer that they're not that complicated and how to test them. But like I said, he looked at me like I was speaking Greek when I was trying to explain it. So It's a pretty basic switch. It's really not that hard to comprehend. They get a little bit more complicated when you're dealing with alternating current and maybe like a 2-pole switch. But for the most part, just a 1-pole switch being drawn to make contact by an electromagnet. It's pretty basic, okay? So that's pretty much how a relay works. So let's test the relay in real life. Okay, so this is the battery I'm going to use. Let's find the correct polarity on this battery first. So it looks like that's the correct polarity, yes. Okay, so we're going to have hot on this side and ground on the other. So we'll make a mark. All right, guys, so I got some power supply here, power and ground from my DeWalt battery. And so we need to, in order to get our single pole contact to move over to 87 so that our power supply line can feed whatever device is being controlled through the switch, we need to power up our electromagnet. In order to do that, we're going to supply power to 86 and ground to 85. So this is our electromagnet here. So we want to turn this over and we want to find 86 and 85, and we should be able to hear it click. So let's do that. So here's 86 and here's 85. So you hear the click of the relay. So that's a good sign. That means that the electromagnet is working and that this switch is drawing over our single pole contact from 87 to 88. So let's take this demonstration a step further and let's power up a circuit. All right, guys, so as you can see, I took it a step further. I wired up this relay to sort of show you guys how it works. It's wired up to control the on and off of this light switch. So 5-prong single pole automotive relays are pretty simple in how they work. I think a lot of people get confused and they think that they're more complicated than they are, but they're not. So let me pull this schematic back out to sort of show you what we got wired up here. All right, so remember, the heart of the relay is the electromagnet. That's the biggest thing you need to remember whenever you come across a relay and you look at the schematic on it. 86 and 85 is the electromagnet, okay? This symbol here is the electromagnet. This is the heart of the relay, okay? So whenever power and ground is supplied to the control side of the circuit or the switch, the electromagnet, once this is energized, okay, it's going to pull this single pole switch from 87A over to 87. So if I have power supply going to my 30 terminal, once 86 is energized, the electromagnet is going to pull this single pole switch over to 87, okay? And now my power supply is going to run from 30 and make contact all the way with 87, and I could then power whatever it is that that relay is designed to power. In this case, it's the light bulb. So that's how we got it wired up right here. So now we're going to energize the electromagnet, okay? 86. That's what this wire is about to do. All right, so once we energize the electromagnet, the light will light up. You can also hear it click. That clicking is the single pole switch inside the 5-prong relay that's being drawn over to make contact from 87A to 87. And then power is going out to wherever it's supposed to go. So relays aren't really that complicated. I thought I'd just sort of show you guys how relays work. All right, so let me just show you how to test the relay real quick, and then we'll try out our new tool. All right, guys, so let's test this relay. We know the relay works. It just lit up our light bulb, but the purpose for doing it is just to show you how quicker it would be if you had a tool like this Relay Buddy, because it is somewhat time consuming to test the relay. So I really wish I had this when I was out doing that diagnostic for that person. I had to do it this way in order to determine whether or not the relay was good. So the first thing you want to do is you always want to start with the electromagnet, because as you recall, this is the heart of the relay. All right, so you want to make sure that the electromagnet has the ability to pass electricity through it. So you want to ohms test it. So you're going to ohms test from 86 to 85, and of course you're going to have some kind of resistance because it is a coil, but you definitely don't want to see infinite ohms. For those of you who don't know what ohms testing is, if you may be new, ohms testing is testing an electrical conductor to see if it has the ability to pass electricity. So take this valve, for example. If you hook electricity to this valve, does it have the ability to pass electricity out to the other end? So that would be an ohms test. So I could take my voltmeter, I could put it on ohms, and I could see if this has the ability to pass electricity through it. So notice the meter. So if you take a look at the meter, it says 0. 0 meaning it has 0 resistance or 0 problems passing electricity from this point to this point. All right. Now, if we were to ohms test, let's say this plastic case, all right, we know that there's no reading on the voltmeter because we know that plastic is not an electrical conductor. Okay, so then we ohms test 86 and 85, our electromagnet. Once we see that it does have the ability to pass electricity through, then we know that when we apply power and ground to the electromagnet, our switch should come to 87. So then at this point, now you're going to take your battery and you're going to jump the electromagnet switch in order to hear it click. So we know once it clicks, 87A should now make contact with 87 and 30. So when this happens, you can then ohms test between 30 and 87 to see if there's no resistance between this point and this point, and you should be able to make a determination at that point if your relay is good. Not just hearing a click is not enough. The relay can click, but then moments after that click have a bit of separation between the contacts, and you heard it click, but the contacts came apart again, and you know, the circuit is now open. All right, so let's check out our Relay Buddy. See what comes in the box. Put a link in the description to my Amazon store. I'll put this in my Amazon store. Comes with a nice little carrying pouch, so that's nice. All right, so this is what's in it. Your Relay Buddy. And it gives you plenty enough cable too to be able to hook this to a battery that may not be that close. All right, so we got our relay powered up. I'm gonna plug it in and see what happens. So this is a lot quicker than ohms testing, jumping the relay and things like that. So of course we got it set to the 5-prong, and we'll hit test and see what happens. All All right, so this is a good relay. We got the green light on it. I like how it switched the relay. It energized the electromagnet and switched over the single pole switch several times before it said that the relay was good. So I do like that. So now what I'm gonna do is I'm gonna deliberately break a relay and see if it still gives us the same reading. All right, so let's pop the cover off of this relay. All right, so we got our relay opened up. So I got the cover off. Let's stick this thing in and make sure that we get a reading before we break it. All right, and I'll also show you guys the switch once the electromagnet is activated. So that's the clicking that you hear in a relay. It's making contact from 87A to 87. All right, so it's good. Now let's break the relay and see what it says. All right, so I broke a few strands of the coil winding. Let's see what happens. Yep, said it was bad immediately. So this thing does work. It's a pretty good tool. I highly recommend it. It's gonna save you a lot of time. If you suspect you got a bad relay, pop it in there, hit test. We see it does work.